Our new unit is on solubility and solutions. There are some terms that you need to know. First of all, we need to think about what are solutions. They are homogeneous mixtures. That means we're dissolving things in other things. So think about dissolving salt in water. Our solute is the substance that dissolves. That would be the salt. Our solvent, which is usually going to be water in this unit, is the substance doing the dissolving, and that would be water. Okay, our solution is the salt water. It's that homogeneous mixture, and remember, it looks the same throughout. So when we were talking about liquids or gas solutions, we said that we could see through them. There are also solid solutions, and they're usually metal alloys, and of course we can't see through that. But something you might be used to is gold. So gold is 24 carats, and that's too soft to make jewelry out of, so they add copper into it, and it makes it more durable for jewelry, and that's your 10 and 14 karat gold. Okay, so that is a solid solution, but that is one that we can't see through. Now, solubility is how much something will dissolve, and we're talking about today if it will dissolve completely. We can look at our solubility rules for ionic compounds. That's going to be another lesson. And we can look at factors that affect solubility, which will also be another lesson. But what you want to know is like dissolves like. So polar solvents will dissolve polar solutes or ionic. So remember, polar molecules are things that have partial charges. They click together like magnets, so they like to dissolve other things with partial charges, which are other polar solutes, or ionic compounds, which are fully charged. Polar solvents do not dissolve nonpolar solvents, and you guys actually know this because water does not dissolve oil. Oil is nonpolar. So if I put oil in water, you'll see two separate phases, and they won't be mixing, so they're not miscible or soluble in each other. So what can we do to speed up the rate of things dissolving or make things dissolve faster? So think about Kool-Aid. When you make Kool-Aid, you put sugar in that water. If I took sugar and it was a completely solid block, it would take a long time to dissolve. That's why we use granulated sugar. So that's crushed sugar, and it dissolves much faster. So surface area will help speed things up when we're trying to dissolve things. More surface area, faster dissolving. We also stir that Kool-Aid, so agitation will make things dissolve faster, and we could use warm water to make that sugar dissolve faster. So temperature will increase the rate of solubility. When we talk about gases dissolving into liquid, you can think about pop. So we put carbonation in pop, and in order to make that dissolve faster, we could put that under pressure, and that'll force the gas into the liquid, but that only works with gases. So the next thing I want to talk about is the solubility curve. So this is something we can look at to figure out how much of something will go into a solution. So this is my solubility curve, and I just decided the substance, say I just made this up, and we have temperature down on our x-axis, and our y-axis is how many grams will go into 100 grams of water. Okay, that's 100 milliliters. And we need to specify that, because if I had more water, I could put more stuff in it, more solute. So this is for 100 grams of water. Now you can see that I have this line, and I call it saturated, and you can think about a sponge. When a sponge is holding as much water as it possibly can, that means water's dripping out of it. We call it saturated. This is like a solution. When it's holding perfectly as much solid as it can, it's saturated. If I could put more stuff in that sponge, so I only dip that sponge halfway in water, it's not saturated, it's unsaturated. It can hold more water. Just like a solution, if it's unsaturated, it can hold more of that solid. Supersaturated is a very special condition where I forced more solid in than I should have been able to. So let's look at those conditions when we look at a beaker. So if it's unsaturated, it's perfectly clear. Everything's dissolved. Why? Because I can put more stuff in it. If it's completely saturated, we usually say that it has solid on the bottom. Why? Because it dissolved everything it could and anything extra fell to the bottom. If I could get it perfectly saturated, it is possible that not a grain fell out, but it can't hold any more. Most importantly to know is saturated means it can't hold any more solid. Now the special condition of supersaturated. Let's think about sugar water. Let's say I have a pot of water and it can hold 100 grams of sugar, but I put in 120, okay? So it's gonna look like this. It's saturated and 20 grams are on the bottom. But then I take that pot and I heat it up. All my sugar is gonna dissolve because solubility increases with temperature. Then I let that pot cool. Now sugar is a crystal substance. And when it cools down, you might think the sugar will fall out, but sugar or any crystal substance has to have something special happen for it to start crystallizing again. So when it cools down, it doesn't start crystallizing, and actually it's now holding more than it should. Now, what is that something special? If I throw in a 1 crystal of sugar, all the sugar that can't be dissolved, that's over that saturation point, will fall out, and I'll go back to the saturated point. So if it's saturated, you'd see stuff on the bottom. If it's super saturated, everything is dissolved. So let's go back to how to read this chart. What is saturated, or how many grams can this solution hold at 10 degrees? Well, here's 10 degrees. If I want to find a saturated solution, I go right to that line. So at 10 degrees, it can hold about 11 grams. So the solution's saturated at 10 degrees with 11 grams. What about 20 degrees? Well, at 20 degrees, I can hold more. So I go to 20, and to find a saturated solution, I will hit that line and I will go over. So at 20 degrees, it can hold about 21 grams of solute. Now, on the line, anything on the line means it's saturated. If at 20 degrees I was below this line, it was only 10 grams, it would be unsaturated. If it's above the line and we say we have those special conditions that it's all dissolved, it would be supersaturated. Okay, so we're going to do a worksheet where I'll show you how to use this graph.